Hello again, Trinity Classical Academy 7th graders. It is I, your host, Mr. Bourgeois. The hour of reckoning is at hand. I don't know. Hey, so I hope you're enjoying probabilities. We're going to do just a small little bit more, and I think this easy week is going to be over. I eased you into it for Easter, but we're gonna finish chapter 10 in earnest. And we're gonna really make a good go at it starting next week. I have just a quick warm-up question for you all. What do you think about this? If I have a deck of playing cards and I randomly pull out two cards, which is the likelier scenario, that they will be the same color or the same suit? That should be easy, right? If you know anything about playing cards, you know that there are 1/4 of the deck are spades, 1/4 of the deck is 1/4 of the deck is comprised of spades, 1/4 is comprised of hearts, 1/4 is comprised of clubs, 1/4 is comprised of diamonds. The diamonds and the hearts are the same color, and the clubs and the spades are the same color. So 1/4 of the deck is going to be have the same suit, but 1/2 of the deck is going to have the same color, so color is likelier. A little more advanced question. What if, let's see, how about this? Is it likelier that I would get a straight or a flush? If you know what a poker hand is, you get 5 cards. A flush is 5 cards of the same suit. So 5 hearts or 5 clubs. The face value does not matter, but a straight is five faces in a row. 1, 2, 3, 4, 5, 7, 8, 9, 10, jack, and so on. It is slightly, here's the spoiler, it's slightly easier to get a straight because there are many more ways to make a straight, and you can do them with any of the suits. They're pretty close, but it works out to where a straight is the easier hand to obtain, and therefore the flush is stronger and beats it. All right, time for the jokes of the week. I figure, guys, since we're on quarantine, we're socially distancing, we're getting a little socially awkward. So there's a meme on the internet called Socially Awkward Penguin, because penguins just don't know how to socialize very well. Like, they get together in their colonies and they just kind of start bumping into each other and waddling around and acting really weird and slapping each other with fins. I have a feeling that's how a lot of you are going to look when you get back into society. Try to reintegrate. You forgot how to talk to people, and so you're going to be like Socially Awkward Penguin. Don't be like Socially Awkward Penguin. Here are the memes. So you wave back. They weren't waving at you. You just pretend to adjust hair. Actually, that's not a bad one. That's a good idea. If you were waving at someone, but they were looking at someone behind you. If you go to a restaurant, you remember restaurants? I think you do. It wasn't that long ago that we had them. A waiter puts out his hand to collect the menus, and you shake his hand. Oh dear. Awkward penguin. So those are Socially Awkward Penguin memes. I find Socially Awkward Penguin is one of my favorite memes because it just is. Because there's like, I don't know how I'm supposed to behave, and then reality sets in and it's awkward. Now, anytime you search the internet for memes, you always run the risk of running into something inappropriate. So I cannot recommend that you search for memes on your own in good conscience, but ask a grown-up and all that. When I say grown-up, I mean, someone who's like responsible for you. All right, page 251, y'all. Look at all that vocab in that yellow box. Finding the probability of events. So in 10.2, we're going to be calculating the probability of an event. So how likely is something to happen? We're going to use Venn diagrams to illustrate those relationships. Now, guys, I want to stress a Venn diagram. You might say, what is the point? This is so easy. Venn diagrams can get very, very complex very quickly. And so even when you think this is very simple, please stick with it and do it anyway, because when you get to more advanced probabilities and statistics and overlapping events that aren't mutually exclusive, if you don't have a good Venn diagram drawing skill, you will suffer in more difficult math. And then we're going to solve problems using probability. So reading from the blue text, use probability, it's a vocab word, probability, to describe the likelihood of an event. So jars Jar A and jar B contain a collection of black and white marbles. You know that jar A has more black marbles than white marbles, and that jar B has more white marbles than black marbles. Suppose without looking, you pick a marble from one of the jars and you want to increase your odds of getting a black marble, you'd probably choose jar A because it's got a higher proportion, a higher ratio of black marbles in it. The word chance implies likelihood. Probability is a way to describe how good the chances are that an event will occur. A number from 0 to 1 is used to express the probability of an event. So look at I'm going to skip to that little number line thing down at the bottom. The number liney thing is pretty great. So they've got this thing. So if you can write it as a fraction, they do it every way. So 0%, wonderful, or 0.0 as just a straight up ratio number. And then they have the that wasn't quite midpoint. We'll go there closer. Then there's 1/2, there's 50%, or there's 0.5. I'm just going to write the percentage. You can have the value be 1 or 100%. It's cursive numbers, deal with it. So over here, an event, the likelihood that an event will happen is absolutely certain. Over here, it is completely and totally impossible. And then there's this whole spectrum in between those two extremes where the number could exist. So kind of like how we had a number line in the real number system that extends on to infinity in this direction and infinity in that direction and has 0 as kind of this magical, neither positive nor negative, amazing number of math oddity. This is very, we call this bound. It's bounded by 0 and bounded by 1. I don't think that's going to be on the checkpoint, so don't memorize that. But it's the set of possible answers is some number between 0 and 1. Some number between 0 and 1 describes the probability of any event taking place. And of course, 0 and 1 refers to 100% and 0 means 0%. So if you have, 0.32, it's going to land somewhere around here. I still have the eraser equipped, so that's okay. You get the idea. Moving on, we're going to turn the page to page 52. I feel like I used to know how to say that in French. All right, we're going to look at example 3. And I'm on a new desk right now, or a different desk than I'm used to, so I'm kind of, it's all kinds of wrong from my back. You flip a fair coin. When they say a fair coin, they mean that it's got a completely equal chance of any of the outcomes. It's like a fair die. The chance of rolling a 2 is the same as the chance of rolling a 6. A fair coin, you have an equal chance of flipping a head or a tail on that coin. It's not weighted one way or the other. There's no bias. So what is the probability that it will land on heads? Well, the word fair means that it's equal, so there's no bias. There's a 50, since there are 2 choices, heads or tails, then the probability of the coin landing on heads is 50. What is the probability that the coin will land on both heads and also tails? A coin cannot land on both heads and tails. The probability is 0. Haha. All right, let's do guided practice, y'all. We're on GP. Go ahead and pause the video. GP 1 and 2. Pausing the video. All right, unpausey. All right, so you roll a fair number die. Find the probability of getting a 4. So there are 6 outcomes when you roll a number die. All the outcomes are equally likely. So the probability of getting a 4 is 1/6. If you wanted to express that as a percentage, you may. I don't know what that is. I suppose I could do it. On your calculator, you take 1 divided by 6 equals 0.167 rounded to the 10th, or rounding to the 100th, I guess you'd say if you're using 0.167, or you could say 16.7% rounding to a 1/10 of a percent. There you go. Now find the probability of getting a 7. It's not a 7-sided die, so the probability is 0. Number 2, when you spin the spinner shown, what is the probability that it will point to a number? 0, because there are no numbers. I think we get it. All right. Moving it on. 253. Find the probability of an event. So the probability of an event. This is important nomenclature, or I guess what is that called? Not nomenclature, but I don't know. I forget what it's called. Important. If someone thinks of it, you can tell me. Notation. It's important notation. This is how we notate it. There we go. That's the word. So this is always the notation for probabilities. You say probability, so P, probability of event A is P parentheses A. So the probability of event A equals the number of outcomes that are favorable to event A, number of successful outcomes or favorable. I'll put favorable. We'll use the vocab word. Number of favorable divided by total number, total outcomes. So the number of favorable outcomes divided by the total outcomes. You see the equation right there. They also give it as m over n. So n is always the number, the total number. N is always the total number. And then I don't know why they use m. I don't know. But n is, you will often in statistical analysis find n. They will call it things like other things. I don't want to confuse you by throwing out new vocab words, but n is generally in the denominator of probability fractions. So example 4. We're on example 4, guys. So find the probability of an event. A pebble is picked at random from a bag that contains 6 gray pebbles, 9 white pebbles, and 5 tan pebbles. Let B be the event of picking a white pebble. All right. So remember, so if we have 6, 9, and 5 pebbles, we're going to think about it this way. So first you want to find the n. What is n? Well, n is the total number of pebbles in the bag. So if I pick out a pebble, there are n different pebbles. The total number is 20. 6 plus 9 plus 5. Then we want to find our m. So what are the number of those outcomes that would equal a success for what the event is? The event is defined as picking a white pebble. There are 9 white pebbles. So that is our numerator. So then we will express that as a percent, just because reasons. So on your calculator, if you did 9 divided by 5, that would work. Or you could remember what Mr. Bourgeois said earlier in a video, where if you have 20 equal parts, each part is 5%. 5 times 9 is 45. Boom shakalaka. Look at what does enthusiastic math student say? He says, you can still express it as a fraction. Yeah, you can. You can. I feel like, do you remember what I said though in the earliest video? I think you do. That when we use a percentage, it converts all ratios and all fractions into a common language so that we can easily compare across events, across events or things. So if I say, hey, I've got this game where you have to pick a white pebble out of this bag of 20, and then you win, or we can play this game where you pick a duck out of a pond, and if the duck has a red sticker on the bottom, then you win. Which game do you want to play? And you would say, oh, well, let's see. There are 50 ducks, and 13 of them have the red stickers on them. You calculate the percentage, and you'll see, aha, immediately that is less than 45%. I want to go with the pebble picking game, or whatever. We should do a game theory class. I wonder if Mrs. Britsky would let me teach game theory. I wouldn't be the most qualified person to teach it, but beggars can't be choosers, right? So we're going to turn the page to page 254. We're going to do GP numbers 3 and 4. Go ahead and do them and pause the video, and guys, then we're done. I didn't give us very much to do this time. All right, good job, you guys. Let's check your answers and learn from the mistakes. Max has 4 short-sleeved shirts and 5 long-sleeved shirts in his closet. X is the probability, is the event of random. I'm making word salad with this. X is the event of Max randomly choosing a long-sleeved shirt. Find the probability of X, the P of X. Express the probability as a fraction. You got it. Books. So there are 9 total shirts And we want to know how many is the, so 9 is the total N. And then we want to know what's the odds of him picking a long sleeve shirt. How many long sleeve shirts are there? There are 5. This is your answer. Right there. Number 4. A box contains 28 pink ribbons and 12 green ribbons. You randomly take a ribbon without looking. Find the probability of picking a pink ribbon. Now, if you're colorblind like me, anytime you're grabbing a ribbon of green and pink ones out of a box, green could be pink. You never know, unless green is like a lot darker. So for me, this would be a true random study. I can't cheat on this. Find the probability of picking a pink ribbon. They say express the probability as a percent. So guys, remember we can't get a greater than 100% chance. So if ever you find, remember this, let me redraw this. You remember this thing where there's 0 over here and 100 over there? Your answer is going to be somewhere between those two extremes. If you ever calculate, oh, it's 117% likely, you know you're wrong. Go back and do it again. So, or it's -2%. No, you're wrong. Do it again. Box contains 28 pink ribbons and 12 green ribbons. Our new denominator is going to be 40, and our numerator is going to be the 28. If you want to punch that into your calculator, I will let you. It's 70%. Guys, that was it. Happy Friday. Have a good weekend. Go outside and play or something. Or calculate what is the likelihood that y'all will go outside and play. I don't know. Is it raining? I don't know. Have the good time. We'll see you on the next episode of Mr. Bourgeois Talks About Math and Stuff. Good night.